In this chapter, we have a six section. First of all, we discuss the first derivative and graphs, and second derivative and graphs in second section. As the application of derivative, we will learn the L'Hopital rule, and in the section 4, we discuss the curve schedule techniques, and section 5 and 6, we discuss the absolute maximum and minimum and related questions, which is called optimization. Since the derivative is associated with the slope of the graph of a function at a point, we might accept that it is also related to other properties of a graph. As we will see in this chapter, the derivative can tell us a great deal about the slope of the graph of a function. In particular, we will study methods for finding absolute maximum and minimum values. These methods have many applications. For example, a company that manufactures backpacks can use them to calculate the price per backpacks that should be charged to realize the maximum profit. Another example, a pharmacologist can use them to determine drug dosage that produce the maximum sensitivity, and advertisers can use them to find the number of the advertisements that will maximize the rate of the change of sales. In the first section, we will learn the geometrical meanings of the first derivative. So, increasing and decreasing function. In this second chapter, third section, we learned how we can make the sign chart. So sign charts will be used throughout this chapter. You will find it helpful to review this section because we will use the sign charts. We say a function f is increasing if on the interval AB f of x2 bigger than f of x1 whenever x2 bigger than x1 and all of them are between the a and b. So in that case, this is increasing on the interval AB, or decreasing f of x2 less than f of x1 whenever, again the same order, x1, x2, b. Okay, so briefly I can explain. On the interval AB, x1 is here, x2 is here, or keeps the order. So f of x1 is smaller than the f of x2 value. So f of a1 is smaller than that value. So this graph is increasing graph, okay? And in the second case, a somewhere here, b somewhere here, x1 here, x2 is here. For all x1 and x2, that's correct, okay? This is the function value. F of x1 is bigger than f of x2, for example. F of x2 is this value. So starting somewhere, function go down, okay? So this is the decreasing function graph. There is a big and important relation between being a decreasing or increasing. For example, let's look to this graph. So until this point, the function is increasing from the left to this point. Let's say this is b, and let's say this point is x equals a, and this is c, for example. So here the tangent line, it has the positive slope. Here tangent line has the positive slope. At that point, the maximum point, tangent line is the slope has 0. Okay, so here the slope is positive their slope is 0 at the top point, and after that point it starts to decrease. So in that case, tangent line has the negative slope. So if f prime is positive, this means f of x is increasing. Okay, so the graph rises, the graph go up. Okay, let's say this is graph, and how it can be, the graph can be increasing by the following ways, like this one, or like this one, or directly this one. Okay, so straight line, the last one is a straight line. If f prime is negative, f of x decreases, so the graph falls, and the shape like that one, like this one, or like that one, or as a line, it can be decreased. One of this graph can be occur. Okay. So in the future, by making the sign chart for the f prime, we will decide either f is increasing or decreasing function. We have an important definition. Actually, to make the sign chart of the f prime, we need the point where f prime changed the sign. So a real number x in the domain of f such that either f prime x equals 0 or f prime x does not exist. This type of the point is called a critical number of f. Okay, so that is the critical number. It satisfies f prime equals 0 or does not exist. Sometimes I said critical point, but point actually should be two tables. I mean x equals a according to this graph, x equals b, sorry. This is critical number. Okay, this point is critical point actually, critical point. But sometimes I can say x equals b is a critical point. In the chapter 2 also we mentioned about the partition number, so maybe I should say something here. The critical number of f belongs to the domain of the f. Okay, x is in the domain of the f, and the critical number are partition number for f prime. But f prime may have partition numbers that don't belong to domain of f, so these numbers are not critical numbers of f. We need all partition numbers of f prime when building a sign chart for f prime. Okay, so when we decide the interval where f prime is negative or positive, you should consider the all partition point. Critical points or critical numbers are not enough to decide the sign of the f prime. If f is a polynomial, then the both partition number for f prime and the critical number of f are the solution of the f prime equals x. So these are the same constant.